Hello student, welcome to our channel, the Physics Point. Today I am going to discuss the third lectures about the general science, and in the previous two lectures we have just discussed the physical quantity. This is the first type of the general science, that is physics. Physics, it is the branch of science which deals with the study of matter's energy and interaction between the matter and energy. In the first lectures we have just discussed the physical quantities, types of the physical quantities, and again they discuss the most important chapters for the all types of the competitive examinations or a special subject examination, that is the motions. In that particular chapter, motions, we have discussed the displacement, distance, velocities, speed, and again the second lectures we have discussed the acceleration and the types of acceleration. The acceleration is the rate of change of velocity with respect to time. This is the acceleration. Mainly three types of the acceleration. If the final velocity of the object is more than the initial velocity, then the produced acceleration is the positive acceleration. Then the complement things, or the final velocity is the less than the initial velocity of that object, then the produced acceleration is the negative accelerations. If the velocity of that object is remains same at every place at every time, then this acceleration is a zero acceleration. Acceleration is the rate of change of velocity or the difference between the final velocity and initial velocity. After that we are discuss the most important things, that is the laws of or Newton's laws of motion. The most important laws, three laws, that is Newton's laws of motions and their applications. The first law, every object in a steady state, it remains steady state, or every object in the uniform motion, it remains in the uniform motion until and unless we are applied external unbalanced force. I will be give one of the examples. If the duster will be keep on the hand or keep on the tables, there are in the steady motions or in the steady state or stationary state up to till whenever we apply certain external force to convert the steady into the motions. The second law, the rate of change of momentum is of the object is equal to the internal force of the object. Momentum, it is the product of mass of the object to the or and the velocity of that object. Momentum, it is the product of the mass of the object and the velocities of that object. Then the rate of change of momentum which we used, and after solving certain derivations we comes to a conclusion: F, the force, is equal to the mass into accelerations of that particular object. Internal mass of the object is equal to the product of mass into the acceleration of that object. And last, third law of the motions, or Newton's third law of the motions, is related to the rocket science. The reaction force, every action force is equal and opposite reaction force. This law is mostly used in the rocket science. In these lectures we have started discussion the circular motions. Before the discussions of the circular motion is the types of different types of the motions. I give the certain examples. The vehicles is under the motions, then the wheels of vehicles is rotated itself, but a bob of the conical pendulums is revolve. What is the difference between the revolutions and rotation? Revolving motions or rotational motions. Difference between revolution and rotation. The difference between the revolution and rotation. Let's take the first title, revolution. These the revolutions. If the object is follow the circular motions, the object is follow the circular motions, then the axis of rotation, consider the object, uh, the bob of conical pendulums. This is the conical pendulums. It will be motions under like this, and the axis of rotations is along the vertical. Then this bob is revolving around this axis of rotation, but the axis of rotation is does not pass it through that particular object. This motion is known as the revolutions. What is the revolutions? If the object is under the circular motion, the object is under the circular motions, or the path of that particular object which are in the motions is the circular, then the axis of rotation of that particular object is outside of that object. This is called as revolutions. Revolution, the axis of rotation is outside. Axis of rotation is outside the object. The object. And the circular motion is the one of the examples of revolution motions. Then what is the second type? That is rotation. Rotation is the opposite or complement things of, that is revolution motion. Rotational motion or rotation motion. It is rotational motion. A vehicle is moving, then the wheels of that particular vehicles is under the circular motions. The wheels is rotated about the axis. The axis will be passes through the center of that particular wheel. It means the axis of rotations of that wheel is passing through that particular wheel. It means the axis of rotation is passing through the object. The axis of rotation is passing through the object, or which is passing through the center of that object or passing through the object. This is known as rotational motion. This is the basic difference between the revolution and rotational motion. Revolution motion, the axis of rotation is outside of that object. The axis of rotation, it means a vertical axis or the axis around that the object is under the circular motion. This is the axis of that rotation. The axis of rotation is must be outside that object. These motions is under the revolutions. And the rotation, that is the axis of rotations is passing through that object. This is the rotational motion. But the circular motion is the one of the example of revolution motion. The circular motion is the one of the example of revolution motion. Let's please take the heading. That is the circular motion. Circular motion. The object which are passes or which are rotating around the circular path, the object of the objects which are moving with the circular path along the circular path, this motion is known as circular motions. Consider the object is here. This is the object, and the center of that particular axis or center of the particular circle is situated at a point O. Then the motion of that particular object, which is known as A, is the circular path. The path of the motions of the point A or the object A is the circular path. Then this motion is known as circular motion. The path of motion, the path of motion of the object is circular. The path of the motion of the object is circular. Then this motion is called circular motion. Then a vector line or a vector is joining from the center of that particular circle to that particular object. This is known as the radius vector. The vector which has drawn from the center of the circles, the circle, center of the circle from the to that particular object. This is known as the radius vector. It is r bar. Radius vector. It is the line which are joining between the center of that circle to that particular object. This is known as the radius vector. Second point is radius vector. The radius vector, it is the line between, it is the line between center of circle to that object. Center of circle to the object which are performing the circular motions or which are under the circular motion. This is the radius vector. Then, what is the angular displacement? When we are discussed about the linear motions or vehicles is the passes through the straight line or the straight line motions or the motions, random motions. Whenever we discuss the first lecture, the point A to the point B, the motions between like this straight line motions or different types of the motions. But these are two different types of the motions in the particular circular motions. It means the angular motion as well as linear motion. Angular and linear motions. Then we have started to discuss the theta, angular displacement. Angular displacement. If you can't see, then firstly listen the words, that is angular displacement, which are denoted as theta. The angle swept by the radius vector at the center of the circle, this is known as the angular displacement of that object. When the object is moving on the circular path, when the object is moving on the circular path, the radius vector swept a certain angle. The radius vector r bar swept a certain angle at the center of the circle. This is called as angular displacement. Or the radius vectors makes angle at the center when the object is moving on the circumference of the circle. The angle makes at the center of the circle when when the object moves, or the radius vectors make certain angle at the center of the circle when the particular object is under the motions. What is the linear displacement? This is the angular displacement. What is the linear displacement? That is denoted as S. The second point is linear displacement. Linear displacement. We know that linear displacement, it is the straight line displacement. The displacement of the particular object which are on the circumference of the circle or path length of that circle, which are denoted as L. The displacement is measured and the on the circle. The displacement of object, the displacement of object on the circle. This is the simplest, shortest definition of the linear displacement, which are denoted as L or S. Then the displacement of the object on the circle, on the circle. This is the shortest definition, simplest definition of the linear displacement. Linear displacement, it is the length or it is the path, it is the displacement which are covered by the object on the circumference of the circle or on the circle. This is called as the linear displacement. Then second concept, angular velocity. Angular velocity, it is the rate of change of angular displacement with respect to time. The angular motion as well as the linear motion is must be similar, but the angular motion is happened inside the circle or at the center of the circle, and the linear motion is happens on the circumference of the circle. This is the basic difference between the angular motion and linear motion. Angular velocity, which is denoted by omega. This is denoted by omega, or this is also known as the angular frequencies. Then the angular velocity, the rate of change of angular displacement with respect to time. The rate of change of angular displacement with respect to time. Then one of the simplest questions or on the simplest point, the unit of angular displacement is must be radian, because this is one of the supplementary unit or the supplementary physical quantity. Plane angle and solid angles are the supplementary physical quantities, and theta is the angle. Then it means the unit of that particular angular displacement is a radian. We know that the linear displacement, it is the length, that is meter or centimeter. Then angular velocity, the rate of change of angular displacement. Rate of change of rate of change of angular displacement, angular displacement with respect to time, with respect to time is called as the angular velocity. The rate of change of angular displacement with respect to time, this is called as the angular velocity. Then the omega is must be theta upon t. Omega is equal to theta upon t. The angular displacement is happened inside the center. Then theta upon t, rate of change of angular frequency, rate of change of angular displacement with respect to time. This is called as angular velocity or angular frequencies. Then the unit is must be radian per second. Unit is must be radian per second. But we doesn't important to discuss the angular velocity, because the angular velocity linear velocity, we know that rate of change of linear displacement with respect to time, the displacement is must be path length of that particular. Okay, let's start. Just revise all these things and rub there. Revolution, the axis of rotations of that revolutions is outside that object. Will be tell in detail when I start the lectures. The rotational motion, the axis of rotations of that particular motions are passing through that object. Then we comes to the important point, that is circular motion. The path length of the motion, the path of the motions of the object which are circular. The path of the motions of that object is a circular path. Then this motion is known as circular motions. Then what is the radius vector? A line joining between the center of the circle to that particular object which are path, which are following the circular motions, then which are obey the circular motion. This is called as the radius vector. Then angular displacement. The radius vector swept to certain angle at the center of the circle when the object is under the motions on the circumference of the circle. This is called as radius angular displacement. The angle makes at the center of the circle when the object is moves. This is known as that is particular angle. Then the linear displacement. Linear displacement, it is, we know that the displacement of the object on the circle, this is known as linear displacement, is denoted as L or S. Then angular velocity, the rate of change of angular displacement with respect to time, this is called as the angular velocity. Then the omega angular velocity is denoted as omega. Omega is equal to theta upon t. Theta is the angular displacement, t is the time, then radian per second. Okay, let's start the new one concept. The directions of angular velocities. Okay, let's start. The direction is must be followed like this. Then the directions is at the center. Angular frequency or the directions of angular velocity or angular frequency is makes at the center, and the directions of the tangential direction is must be the linear velocity is the tangential velocity. When the object at the place B, then the direction is like this at the place C or at the place D. The linear velocity, the directions of the linear velocity is the tangential directions, and the directions of the angular velocity is at the center. Then linear velocity. Linear velocity. The velocity of the rate of change of linear displacement with respect to time doesn't interest writing the definition. We directly write the equations, which is denoted by V. V is equal to S upon T or L upon T. In the sum books, we use the S or L. Then we know that the velocity V equal to, that is the meter per second. Meter per second. That is the S is the linear displacement, T is the time. We must be discussed the unit of velocity in the previous lecture. But we try to discuss the relationship between the angular and linear velocity. Relation between linear and angular velocity. Linear and angular velocity. And we just write the important equation, that is V bar is must be equal to omega into R bar. Then omega bar is must be equal to V upon R. This is the most important concept about the relationship between the angular velocity and linear velocity. R bar is the radius vector which are discussed before to starting this all types of the concept. Then velocity V bar is equal to omega into R bar. Then the accelerations, angular and linear accelerations. Angular and linear accelerations, the rate of change of angular velocity with respect to time. This is the angular acceleration, which is denoted by another concept. And the rate of change of linear velocity with respect to time. This is the another one accelerations. Then this is the linear acceleration. The directions of the linear acceleration towards the radius, along the radius, but the directions of the linear angular acceleration is follow the right hand thumb rules. If the angular accelerations is, if the object is moving like this, then the angular acceleration is upwards. When the object is moving like this from the D to the A or opposite direction, then the directions of angular velocity is downward directions. But the most important concept which will be used to following the particular circular motion, that is the centripetal force and centrifugal force. The centripetal and centrifugal force. This is the most important concept. We will be try to miss the centripetal force. Centripetal force. The force of acting on the particular object which are performing the circular motion. The force acting on that particular object which are performing the circular motions is along the radius and towards to the center of the object. This is called as centripetal force. The force acting on the object which are performing or performing which is performing circular motion along the radius vector or along the radius, and this is the most important, and towards to the center, towards to the center. This is called as the centripetal force. When uh, the vehicles on the well of the death which are performing circular motions, the force which are keep try to keep the path or the vehicles on that path, or which are try to pull the particular object towards to the center, this force is known as the centripetal force. The centripetal force, the definitions is like this, and the equations F is equal to m v square upon r. Then m is the mass of that particular object which are performing the circular motions. V is the linear velocity of that particular object which are performing circular motions, and r is the radius vectors. And if this denoted as the centripetal force is opposite, then we are denoted as negative signs. Then these similar equations written in the form of angular frequency, then F is equal to m. What is the value of v square is omega into r. That's why we are discussing the relationship between the linear and angular velocities divided by r, the whole square. Then F is equal to m into omega square into r square divided by r. This will be, then the square of r and the 1r will be cancelled out. Then F is equal to the centripetal force or centrifugal force m omega square into r. M omega square into r. The unit of the force is Newton. Then this is the centripetal force, the force acting on the object which are performing the circular motions along the radius and towards to the center. Please underline that particular word, that is towards to the center. Must be bracket it or highlight it. Then another one force, that is centrifugal force. The same definition but change these words. Along, towards, then away from the center. The force acting on the object which are performing the circular motion. I will be dealing about the centrifugal force. The force acting on the object which are performing circular motion along the radius and away from the center of the circle. This is known as centrifugal force. But whenever we're dealing with the centripetal force, we use the negative sign. Whenever we're dealing with the centrifugal force, we don't use the negative sign. Centripetal force is opposite the radius. It means we use the minus sign. Okay. Then this is the basic difference between the centripetal and centrifugal force. Then again, in the next lectures, we have started discussions of this gravitations, and after the gravitations, we are again discuss the satellites. Satellites and gravitations are our next task to discussions, and maybe that is the fourth lecture or fifth lectures to complete the gravitations and the satellite concept. Gravitation, it is the force which acting between the two masses is directly proportional to the product of their masses and inversely proportional to the square of distance between them. This is must related to the Coulomb's law. Gravitational force law is must be related to the Coulomb's law or as similar to the Coulomb's law. But in the Coulomb's law, we are dealing with the attractive force as well as the repulsive force. If the same charges, same positive charges are repulsed to each other, different charges, positive and negative charges attract to each other. When we are dealing with the Coulombic laws, we are discuss both things. We are consider undertaken under the considerations of both things, attractive force and repulsive force. But the gravitation force is must be only and only attractive force. We are discuss in the next lecture. The please most important topic is gravitation.